Hello, my dear students. Today we are going to learn Laplace transformation. Okay, the new topic Laplace transformation. Okay, so Laplace transformation for a function f of t. Okay, f of t is defined as 0 to infinity e power minus st f of t dt. Okay, there are some conditions with f of t also, but here we will learn the basic functions for which we can have this integral. Okay, so now first we are going to find out Laplace transformation of 1. So see, in 1, if f of t equal to 1, then what is L of f of t? Okay, so now see here, now L of 1, L of 1. L of 1 is, see here, in place of f of t I have written 1. Okay, so in place of f of t I have to write 1. So 0 to infinity e power minus st 1 dt. Okay, s is constant independent of t. Okay, so now what is the integration of e to the power minus st? It is a e power minus st by minus s, and limit is 0 to infinity. Okay, so now 1 by e power minus plus st 0 to infinity. So after putting the limit, what you will get? 1 by minus s 0 minus 1. So you will get 1 by s. Okay, so L of 1 is 1 by s. So now if f of t is, so next one, now we are going to find out for the function e to the power at. Okay, what is L of e to the power at? Okay, so now similarly just put e to the power at in place of f of t and integrate it to get the formula for L of e to the power at. Okay, so now see here, 0 to infinity e power minus st e to the power at dt. So we can write this 0 to infinity e to the power minus s minus a t dt. Okay, so after integrating, what you will get? 1 by e to the power minus s minus a t by minus s minus a, okay, 0 to infinity. So minus s minus a, and putting the limit, you will get 0 minus 1. Okay, so now e power s minus a. Okay, so now we have two formula. One is L of 1. L of 1 is 1 by s, and L of e to the power at is 1 by s minus a. Okay, so similarly we can find, try to do yourself, what will be L of cos of 80. Okay, what will be L of cos of 80? Okay, you can prove this, that L of cos 80 is s by s square plus a square. Okay, next formula, L of sine of 80, it will be a by s square plus a square. So what is the difference between these two formula? You can see here, for the first formula is s by s square plus a square, and for the second one is for sine 80, a by s square plus a square. And formula number 5, what is L of cos of h at t, hyperbolic function, cos of h at t. Okay, cos of h at t. So it is almost same with this formula, except see the difference, s square minus a square. Okay, here in place of s, in place of plus addition comes minus. Okay, so similarly for sine h at t equal to a by s square minus a square. So formulas are very easy to remember. Okay, so you can see L of 1 is So what was the formula number 1? Formula number 1 is, you can see L of 1 is 1 by s, L of e to the power at is 1 by s minus a, and cos of at is s by s square plus a square, cos of a, and this is cos h at. Okay, the difference is here plus and here minus, sin 80 and here sin h 80. Okay, the difference is you can see. Okay, so one more formula, 7 L of t to the power n. Okay, L of t to the power n is n factorial by s to the power n plus 1. Okay, so here n is a natural number. Okay, so for any n also, for any n we can find Laplace transformation. Okay, so if n is not natural, then what will be t to the power n? Formula for t to the power n, it will be gamma n plus 1 by s to the power n plus 1. Okay, so here if n is not natural number, some another number, okay, for any positive n. Okay, so now see, we have 7 formulas and we will apply this formula to solve in some problems. Okay, so now see why we are learning this topic. So this topic we are learning to solve some ordinary differential equations. Okay, so there are some problem unable to solve by directly. Okay, for some problem we will apply this Laplace transformation for solving ordinary differential or partial differential equations. Okay, so now see some properties. Okay, now see some properties of the differential equations. So do remember this formula. So let us take some examples before starting the property. For example, what is L of cos of 60? Okay, so what is cos of L of 60? So see this formula and use this formula, s by s square plus 6 square. Okay, so for suppose L of, what is L of t cube? Okay, so for L of t cube you can use this formula because this 3 is natural number. If 3 is not natural number, then you have to use this formula. Okay, so 3 factorial by s to the power 3 plus 1, that will give you 4. Okay, that will give you 4. So now some properties of the Laplace transformation. So properties of Laplace transformation. Now the first property, that is called linear property. Okay, so property 1 is L of a, this is a is constant, f1t plus b f2t equal to a L of f1t plus b L of f2t. Okay, so this is the linear property. This is called linear property. So now proof of this property, very easy to prove. Just use the definition of Laplace transformation. Okay, so see, L of a f1t plus b f2t. Okay, so what is the definition? Definition was here, first 0 to infinity. You have to remember 0 to infinity, then e power minus st, e power minus st, and whatever inside this bracket that you have to write here. Okay, so what is this? This will be a f1t plus b f2t dt. Okay, so now see, so we already know for integral, we can here multiply this term with here this term and this term. So also we can distribute this integral. Okay, so this can be written as a into 0 to infinity e power minus st f1t dt plus b into 0 to infinity e power minus st f2t dt. Okay, so now see what will be this. So using Laplace definition of Laplace transformation, so here this is f1t, so what we have to write, a into L of this one, f1t, okay, plus b into L of f2t. Okay, so this is the linear property, and we have proved. Okay, so one next property is called shifting property. First shifting property, okay, so first shifting property is, see, if L of f of t equal to f of s, okay, f of s, then L of e power at f of t f of s minus s. Okay, so this is called first shifting property. Okay, so now see what is the how to prove it. See, prove L of e power at ft. Okay, so what is the definition of Laplace transform? Using definition of Laplace transformation, we will prove it. So first we write 0 to infinity. In the definition there is e power minus st, and whatever inside this bracket, okay, we have to write here. So what is this? E at f of t dt. Okay, so now see, 0 to infinity e power minus s a t f of t dt. Okay, so now see what it becomes. So now see 0 to infinity e power minus r, okay, t f of t d t. Okay, so what is r? R equal to s minus a. Okay, r equal to s minus a. So what is, after integration, what will be this? It will be function of r. Okay, f of r. Okay, so what is f of r? F of r is f of s minus a. So to understand this, that means if L of f of t is f of s, then L of e to the power at equal f of t equal to f of s minus a. So why I am writing this? So to understand this, see now the definition. So in this definition, you can see after integration, it will contain only the variable s. So it is f of s. Okay, so now if L of f of t is f of s, then by first shifting property, L of e to the power at f of t equal to f of s minus a. Okay, so now application of this first shifting property and the linear property. Okay, so let us take one question, one example. L of e to the power at sin bt. What will be L of e to the power at sin bt? Now see, first we are going to use this shifting property. So suppose this is f of t. Okay, this is f of t, and this is f of t, this is e to the power at. So what is, to solve this, what is L of sin bt? Okay, what is, see, this is the formula. What is L of sin bt? Okay, you know the L of sin bt is b by s square minus s square plus b square. Okay, this is the formula for L of sin bt. Now see, L of f of t equal to f of s. So this is f of s. Okay, so now here e to the power at is multiplied by f of t. So all s in the right hand side, all s will be replaced by s minus a. Okay, s minus a. Okay, so here what will be this? B by s minus this is a whole square plus b square. Okay, so one more questions. Let us example L of e to the power suppose 5t cos of 7t. Okay, this one. So what is the formula for L of cos 70? Okay, so first we have to know the formula for L of cos 70. So we know L of cos 70 is s by s square plus 7 square. This is the formula for L of cos 70. Now as it is multiplied by e to the power 5t, so all s in the right hand side will be replaced by s minus 5. Okay, all s will be replaced by s minus 5. So here what will be this? L of e to the power 5t cos of 7t equal to s minus 5 by s minus 5 whole square plus 7 square. Okay, so this is the application of shifting property. Okay, so one more example, example 2, example 3. What will be L of e to the power at t to the power suppose this is 5. Okay, so what is the formula for t to the power n? T to the power n formula is n factorial by, if n is natural number, n factorial by s to the power n plus 1. Okay, so what will be t to the power 5? T to the power 5 is 5 factorial by s to the power 5 plus 1, that is 6. Okay, so now it is multiplied by 80. So using fast shifting formula, what fast shifting formula says that fast shifting formula says that all s in the right hand side will be replaced by s minus the coefficient of t. Okay, the coefficient of t is a here. So here what will be right? I have to write 5 factorial by s minus a whole to the power 5 plus 1, this is 6. Okay, so let us take one more example, example 4. L of e to the power minus twice t cos of 3t. Okay, so here also we can use the shifting property. So okay, what is L of cos of, so here what is L of cos of 3t? Okay, the formula for cos of 3t is s by s square plus 3 square. Okay, so now we are going to use the fast shifting property here. So what will be this? All s here in the right hand side, all s will be replaced by s minus the coefficient of t. Okay, what is the coefficient of t is minus 2. So here s minus 2 by s minus 2 whole square plus 3 square. Okay, after simplifying, what you will get? S plus 2 by s plus 2 whole square plus 9. Okay, so what we have learned here, we have learned the formula for Laplace transformations. Two property, one is called linear property and another is called fast shifting property. Okay, so now the summary of this class is, what is the summary of this class? First, the formula for Laplace transformation f of t equal to 0 to infinity e power minus st f of t dt. Okay, this is the formula. Okay, so after integrating, what you will get? You will get this is a function of s. Okay, so now the formulas that we have learned for f of t are 7 formula we have learned here. The first one is L of 1 equal to 1 by s. Okay, next, second, L of e to the power at, very easy to remember, 1 by s minus a. Okay, so L of 1 is 1 by s, L of e to the power at is 1 by s minus a. Next, 3 L of cos of at. Okay, L of cos of at equal to s by s square plus a square. Okay, next 4 L of sin at or bt, whatever you can value want to take, you can take here. So here it is will be a by s square plus a square. Okay, next 5 L of hyperbolic function cos of h at equal to s by s square minus a square. So difference between the trigonometric function and hyperbolic function is that for trigonometric function here it is plus, and for hyperbolic function it is minus. Okay, similarly for trigonometric function here it is a by s square plus a square, or for hyperbolic function sin h at sin h represents the hyperbolic function, it will be a by s square minus a square. Okay, and the last one 7 L of t power n. So for any t, any n, any real number, okay, any real positive real number, it will be gamma n plus 1 by s to the power n plus 1. Okay, so gamma function you have learned in your first semester. Okay, gamma function, what is gamma function, you have learned in your first semester. And the property 1 is called linear property. The property 1 is L of a f1t plus b f2t equal to a into L of f1t plus b into L of f2t. Okay, this is the first shifting property. This is called property number 1. This is called linear property. Okay, name of this property is linear property. You have learned this property in linear algebra also. Okay, so property 2, that is called shifting property. That is first shifting property. That means there is one under shifting property, that is called second shifting. So here today we are learning first shifting property. The property states that if L of f of t equal to f of s, okay, the right hand side should be a function of s, then if we multiply e to the power at f of t, then it will be f of s minus a. Okay, so I have explained this Laplace transformations, very basic formulas, and I have proved this L of 1 and L of e to the power 80. Now you have to prove yourself what is how to find L of cos of 80, how to find sin of 80, how to find L of cos of 80, and the remaining formulas. So for this I will give some hints. Okay, so all of you know the formula e to the power I theta equal to cos of theta plus I sin of theta. Okay, one of the most important formula for Laplace transformation. And one another formula that is known to you, e to the power a theta equal to cos of h a theta plus sin of h a theta. Okay, so now here see the formula 3, that is cos of 80. Okay, so in place of theta we will put t. Okay, so how to derive this? Okay, so now see, using these two formula, so here we will derive the remaining Laplace transformations. So for cos of 80, this is a trigonometric function. We will use this formula. So now see, what is e to the power I t cos of t plus I sin of t. Okay, so what is e to the power minus I t? It will be cos of t minus I sin of t. Okay, so actually I have to write here e to the power I a t. Okay, e to the power I a t cos of a t sin of a t and I a t cos of a t minus sin of a t. Okay, so if you add this, what you will get? E to the power I a t plus e to the power minus I a t equal to 2 of cos of a t, and this is minus, this is plus, cancel out. So what is cos of a t? Cos of a t equal to e power I a t plus e power minus I a t by 2. Okay, so now we can use this cos of a t, this part here. So see what will be this, L of e to the power I a t plus e to the power minus I a t divided by 2. Okay, so now see 1 by 2. Okay, I have used now the linear property, e to the power I a t plus 1 by 2 L of e to the power minus I a t. Okay, also we know the formula for e to the power a t. Okay, also we know the formula for e to the power a t or 5t or w t, whatever constant you can choose here. Okay, for e to the power a t is 1 by s minus a. Okay, so in place of here, what is this? E to the power I a t, so I a t will come here. Okay, so if it is 5, then here 5 comes. If I t I a, then here I a will come. So here what will be, what we have to write? 1 by 2 into 1 by s minus I a. Okay, so plus 1 by 2 into, so here already 1 minus 1 by s minus I a. Okay, so 1 by 2 you can take common, 1 by 2 you can take common, 1 by s minus I a plus 1 by s plus I a. To simplify this, after simplifying, what you will get? 1 by 2, if you take LCM, you will get s minus I a into s plus I a, here s plus I a plus s minus I a. Okay, so this I is, what is I equal to root over, that's complex. Okay, complex term. So what you will get here, it will twice s, and here s square plus a square. Okay, s square plus a square. So 2 to cancel, you will get s by s square plus a square. Okay, so now we have proof here, L of cos of a t equal to s by s square plus a square. So what we have used here, we have used to prove this, we have used this formula. Okay, so similarly for sin a t, we can use this formula to derive the Laplace transformation of sin a t. Okay, so for cos function, that means for cos h t and sin h t, to derive this formula we can use this formula. Okay, so using this formula we can complete this derivations. Okay, so L of 1 I have derived L of e to the power a t, so L of cos of a t. So do yourself, okay, do yourself this formula. Okay, so prove this formula or derive this formula using the given formula I have given already. So to prove this you have to use one more formula that is called gamma function. Okay, so for this you have to use this formula that is called gamma function, that is gamma n plus 1 equal to 0 to infinity e power minus x to the power n dx. Okay, so using this formula you can derive this question number 7 formula. Okay, so see this video slowly and try to understand all the things. So create your questions in your mind and ask me those questions. For example, one question may arise in your mind that can we have a Laplace transformation for all functions? Okay, so answer is no. Okay, there are some conditions on the functions. For those functions only we can have Laplace transformations. Okay, one more questions you can arise in your mind, why we are learning this Laplace transformation. Okay, so using Laplace transformation we can minimize the labor time of solving ordinary differential equations. Okay, there are some ordinary differential equations or partial differential equations where time more time takes. Okay, so for some particular type of differential equations we can use Laplace transformations, which which saves the time to solve the problem. Okay, and these are the basic formula, and these are the 7 formula I have given, 7 formula, and I have given property 1 and property 2. There are some another property also in your syllabus. Those all property I will discuss here, and if you have any kind of doubt or questions, you must ask me. Okay, so I will provide some homeworks. Do those homeworks and submit as soon as possible. Thank you.